Hey, hello guys, welcome back to my channel, Data Science with Gagan. So I got another project for you guys, which is again on text classification, but this time text classification using machine learning algorithm. So as I spoke in the end of my last video, that in my next video I will cover up text classification using any machine learning algorithm. So I'm going to use multinomial Bayes classification algorithm for text classification purpose. So in this video, first we will learn something about multinomial Bayes classification algorithm, like what is this algorithm and how it works. And then we have another topic which is TF-IDEA vectorizer. So we will learn something about TF-IDEA vectorizer and how it works. And then we'll see how can we implement both TF-IDEA vectorizer and multinomial Bayes algorithm for text classification. So let's understand multinomial Bayes classification algorithm first. So what is this algorithm? So it is a supervised machine learning algorithm which is commonly used in natural language processing and text classification tasks. And as you can see here, it is a probabilistic algorithm which calculates a posterior probability, which assumes that there should be no dependencies between the features. And it follows two assumptions. The first assumption is features are independent of each other given the class label. And then second assumption is each feature should follow the multinomial distribution. Now let's have a look at its working, how it works. As I told, it is a probabilistic algorithm. So it computes the posterior probability of each class given the input features using the Bayes theorem, and then it assigns the class with the highest probability as the output. So in this way it works. Here I have mentioned what another example which is of text classification, which is classifying email as spam or not spam on the basis of email text, that we can do using multinomial Naive classification algorithm. Now let's understand something about TF-IDEA vectorizer. So what is this? So TF-IDEA stands for term frequency inverse document frequency. It is a vectorization techniques which is used in information retrieval and text mining to convert our textual data into a numerical form, which is commonly used with machine learning algorithms. So as you can see here, it is consisting of two parts. One is TF and second one is IDF. So what is this? So TF stands for term frequency. So it measures how frequently a term appears in a document, and it is calculated as the ratio of the number of times a term occur in a document to the total number of term in the document. And it assumes that if a term that appear more frequently in a document are more important to that particular document. And then IDF measures the importance of a term across a collection of documents, and it is calculated as the logarithm of the ratio of the total number of documents to the number of documents containing that particular term. The IDF of a term increases with the rarity of the term across the corpus, meaning rare terms are weighted higher. And TF-IDF vectorizer TF-IDF technique combines both TF and IDF to assign a weight to each term in a document in the corpus. It gives a higher weight to a term that are frequent within a document but rare across the entire corpus. So this is how this technique works. So now let's look at its implementation, that how can we implement both TF-IDF vectorizer and multinomial Bayes classification algorithm for text classification. So first we are importing all the necessary libraries here like sklearn and NLTK, where we will use NLTK for text cleaning and text pre-processing purpose, and whereas we will use sklearn for information retrieval and modeling purpose. So let's begin with reading data. So here in this line we are just reading out the data from the directory, and then here we are checking like what is the length of our data. So here you can see it is more than 4 lakh, right, which is too much for the system to process or to train our model. So what we will do, we will select some samples from our data, from this data, to get our model trained. So here first I'm checking out the category that are presenting in our target variable. So here you can see where here we have 4 categories. So first is B, T, E, M. So here on the basis of these categories, we will select the data. So how I'm selecting data here? So what I'm doing, I'm selecting 10,000 rows for each categories here. for each category here. So once we have this data, we can save it. So in the final, we will be having 40,000 rows to train our model. And along with this train data, we are saving out our test data so we can evaluate our model post training it. Once we have got our data, we can save it into one directory. And here I'm reading out this data, and then here we will follow the same step that we did in the LSTM part, where we will begin with the concatenation of all the text into sentence. So same we are doing here in the 70th cell. So here we are concatenating all the text into one sentence. So here in this line, in 72nd line, we are calling up this class which is word lematizer. We are using this class for lemmatization purpose, as we use stemming for LSTM. Here we are going to use lemmatization. The basic difference between lemmatization and stemming is stemming doesn't care about the meaning of the sentence while converting a word to its root word, whereas lemmatization takes care of it. It takes care of the meaning of a sentence while converting a word to its root word. So here in this line, in this cell, what we are doing, first we are creating a stop words list, and then here we have created a MPD sentence. So here what we will do first, here in this line, right, in the third line, we are checking out if there is any special symbol, then we are removing it. And then we are doing the tokenization means to break a sentence into words. And then I'm checking if any word which is a stop word in the given set of words, then I'm removing it. And then here I'm doing lemmatization process to convert a word to its root word without affecting the meaning of a sentence. And then I'm storing it, this sentence, at a particular location in the data frame. And then post doing it, we now you can see like these columns like title, publisher, category and story, and host name are of no use, so we can remove it. So I'm dropping them off here. And then now you can see like this is our final data, category and single text. Based on this single text, we are going to predict the category. So here in this line, I have segregated this data into x and y. Y will consisting of these categories, and x will consisting of the single text. So here you will see how can we use TF-IDF vectorizer, or how can we implement TF-IDF vectorizer in our code. So we can have a numerical representation of our textual data. So we can write this code in two ways. So first way I have written here, which is where where I'm calling up this count vectorizer, so we can have a bag of words, and then we can pass this bag of words to this TF-IDF transformer, and then this TF-IDF transformer will take this bag of words and will assign a weight to each word in each document of a corpus. This is the first way, and instead of this, you can write a simple code where you will use TF-IDF vectorizer directly. The output will remain same for both the techniques. So here you can see in this cell I have written down this function plot confusion matrix, so we can have a look on confusion matrix that we'll get from our trained model. So we will be having some idea on our true positive, false positive, true negative and false negative numbers. And then in this cell 39, I am creating up this model by calling up this class multinomial NB. This class will basically represents multinomial Naive Bayes classifier. And then in the next line I am fitting this model on our data. And then here in the third line I'm checking out its accuracy, what how much accuracy we are getting for this model on our training data. So you can see we are getting 99% accuracy on training data. So once we are done with this model training, we need to check or we need to evaluate our model, how well it is fitted on our training data and how accurate it is. So here you can see I'm to evaluate this model, I'm reading the same data that I had saved previously. And then here you can see I'm following up the same steps that I followed during the training data, and then getting the numbers using the same trained count vectorizer and TF-IDF vectorizer. And then here I'm getting the predictions from the model, and then I'm plotting out this confusion matrix. So we can see that so we can see the number of true positives. We are predicting these numbers with 82% accuracy. So here you can see we got 82% accuracy on test data, which can be increased or which can be improved further by doing model fine tuning. And for model fine tuning, you can use any fine tuning technique like grid search CV or random search CV. So I'm telling again, you can use any machine learning algorithm for text classification purpose, as there are multiple machine learning algorithms specifically designed for text classification like SVM, which is support vector machine. So it's again on you guys which algorithm you want to use, but I will suggest one thing: select two or three algorithms and do train them on your data and then evaluate them. Which algorithm is giving out you good accuracy? The algorithm which is giving you a good accuracy, just select that algorithm for your data. That is all for this video. We will try to cover a new topic in the next video, so stay tuned. Thank you guys. That's all for this video. Before leaving this video, please do like and subscribe my channel to keep me motivated so I can create many more videos for you guys on data science projects. And please don't forget to press bell icon to get the notification for the next video. Thank you guys.